For this example, we're going to start by highlighting the important information. Now it says in here that a gas in a steel container at 280 Kelvin and 55.5 kPa is heated up until the temperature is 100 degrees Celsius. Now they want to know what is the new pressure. So if you take a look at it, 280 kelvins, that is a temperature, and 55.5 kPa is a pressure, and since it says at and, that those two go together. So what we're left with is, this is also another, this is a temperature, pressure, 100 degrees Celsius is a temperature, and pressure is what we're looking for. So those two are going to go together. So now let's go over to the left side of our page and write our variables out. So since the first two are together, we're going to say that's T1 and P1. So T1 is 280 Kelvin. P1 is 55.5 kPa. Now since we have another T, we're going to call that T2, and this one's in 100 degrees Celsius. Now we don't like Celsius, so we're going to add 273, and our new temperature 2 is 373 Kelvin. And what we're trying to find is P2, so we're going to put a question mark there, and we're going to solve that into kPas. Now since we're looking for the pressure, we're going to keep that on top, and we're going to use Gay-Lussac's law, which is P1 over T1 equals P2 over T2. And now let's plug in our values and solve. So P1 is 55.5 kPa over T1, which is 280 Kelvin, equals P2, which is question mark, kPa, over T2, which is 373 Kelvin. Now to solve for this, we're going to extend our fraction line out on both sides, and we're going to multiply both sides by 373 Kelvin. So it goes away on the right side, and then the kelvins go away over here. When we multiply now, 373 times 55.5 divided by 280, and I get 73.9 kPa, which is now our P2. And that's your answer.